G'day YouTube, welcome back to the VK8FOAS YouTube channel. We're going to be talking about DVB-S2 again, guys. That's a topic that has been taking up a lot of my radio hobby recently. So DVB-S2 is television satellites, right? And I've mentioned before in other videos on the subject that there's a lot more than just television goes over these satellites. There's like internet traffic, like ISP downlinks. We've got like voice over IP, we've got like emails, all kinds of stuff goes over TV satellites, not just television and radio. So there's this technology called generic stream encapsulation, and generic stream encapsulation is the new kid on the block when it comes to transmitting data over TV satellites. Back in the day, it used to be called MPE, which stands for multi-protocol encapsulation, but that's more sort of 10, 15 years ago now. And in the modern day, satellite internet providers will use, or not so much ISPs, but anybody that needs to access data over a satellite will probably be using a generic stream encapsulation. So it's just a way of sending IP traffic over a TV satellite, pretty much. I'm not an RF or satellite engineer, but I'm led to believe they're encoding the data directly into the baseband frames of a DVB-S TV transponder, and a transponder is the signal that the satellite is beaming onto the planet Earth. So using some consumer grade satellite equipment, we can actually receive and decode these IP traffic links, which is really fun. And yeah, if you guys want to know more about TV satellites and what you can get on them, I've got some videos here, where, decoding voice over IP, we're decoding unencrypted emails. There's all kinds of stuff you can do with consumer grade satellite television stuff. So yeah, that's really cool. We're going to need some hardware for this, obviously. So I'm using a virtual machine for this, guys, okay? It's not the best way to do this, but I'm too scared about breaking my main computer's decoding setup. So I've set up a virtual machine, and we all know that virtual machines can only have USB devices pass through to them, right? Normally, the best way to do this would be with an actual PCIe card that can receive satellite signals, but I'm using a USB. It's not the best way to do that, and I'll explain why later. So I'm using a TBS. Whoa, what's going on here? I'm using a TBS 5927 because I can pass this through to VMware Workstation inside a virtual machine. And yeah, again, I'll show this picture again. This is me looking very happy with a new purchase. This dish is sort of almost a year old at this point, but this was the day that I purchased that dish and I brought it back home from the shops. It's 1.2 meters. It's a very nice satellite dish. And yeah, this is the dish I'm using for this tutorial here. It's just a 90 centimeter Foxtel pay TV dish we have here in Australia. I've got a universal LMB and it's got a motor on it so I can like steer it around and stuff. And then yeah, I've just got the coaxial cable which actually leads indoors to my studio here. So yeah, that's just the rundown on the equipment, but this tutorial will be for people that already are proficient in satellite. They've probably got a setup at home, stuff like that. Shout out to Chris as well. Chris, he's getting into this stuff too, so I'm actually partly making this video for him. And later on in the tutorial, I'll be using my internal PCIe card. This is a beast of a DVB-S2 card. They don't make them anymore, but this is basically the best one that was ever made by this company called TBS. So not made or sold anymore, unfortunately. But yeah, this is the cream of the crop, and that's what I use for my daily satellite TV hobby. We're going to need some software as well, guys. So we're going to need Python for Windows. We're also going to need it in Linux too, but forget about the Linux stuff for now. We're going to show that later. I'll get you going first in Windows, Windows is not the best way to do this. But yeah, I'll explain all that later. So we're going to need Python for Windows. We're going to need an application called TBS TS Recorder, which is here. We're also going to need, I'm going to need the drivers for my 5927 too. So we're going to do everything from the start. Driver installation, yada, yada, yada. So And we're going to need Wireshark as well. So I recommend always using 3.6.2 because the later versions of Wireshark, like 4 point something, they seem to break voice over IP decoding for some reason. I can never get voice over IP to work in the later versions of Wireshark. I just stick with 3.6.2. It just works for me. And yeah, later on, we're going to be installing WSL, which is Windows Subsystem for Linux. So that's a Linux layer that runs within Windows, kind of like a virtual machine. And that's how I use Linux for this generic stream encapsulating, decoding stuff. So anyway, that's later on in the tutorial. I'll get you going in Windows first, and then we'll talk about the better way to do it with Linux later. So that's everything we need. I'm going to minimize that. I've already downloaded everything in my working directory here. So yeah, the first thing we're going to do is we're going to install Python. So we're going to tick this box down here, add Python exe to path, and we're just going to hit install now. I should have mentioned before too, the application we're going to be using later, it's Linux and Windows, but it's a Python application, so it could run on both. It's called GSE Extract. That's the program. That's the star of the show for this. It's made by James Pavor, who's a researcher at some university in either America or England, I can't remember. And he wrote this tool as a open source forensic tool to basically decode satellite internet traffic, basically. And there's no encryption on these things. The layer 3 stuff is not encrypted, so you can see all the traffic. It's like the point of view typically is you're behind the router, which is a really, really unique point to analyze network traffic from. So we're going to disable the path limit here. And then we're just going to click close, and that's Python already installed. We're going to install Wireshark next, so we need Wireshark for many things in this tutorial. So we're going to just install this like normal. Just click next, next, next for everything. You don't need to change anything. We definitely need NP-cap, so do not untick that box. We press next. We don't need USB cap because we're not touching anything to do with USB. This is installing Wireshark, and then a second window will open up, and that's when we install NP-cap. So yeah, what I was saying before was all the layer 3 stuff is the layer 3 in the network OSI model is all unencrypted, and then obviously vendors and maybe if it's a corporate LAN, they'll be running a VPN on top of that. So we can see like the VPN packets. We can't see the traffic though. So that's just something that you'll see a lot of IPsec VPNs, a lot of Quick Protocol, which is another VPN, I believe. Yep, so we're just installing NP-cap now. But yeah, you guys shouldn't use this tutorial to be naughty and eavesdrop on people's private traffic. You should only use this tutorial if you are an internet satellite user and you want to evaluate the security of your ISP. You should only use this tool. Don't use it for any other purpose. Only intercept your own traffic. Oh yeah, I forgot to mention I've got my trusty stream video recording beer here. Okay, that's Wireshark and NP-cap finished. Okay, next what I'm going to do is I'm going to install my TBS 5927 drivers. So I'm just going to extract this folder, or archive should I say. I'm going to install this. These are the drivers for my satellite television USB card. Okay, I'm just going to go to Device Manager and just make sure that my TVS 5927 is successfully installed. Excellent. The next thing we're going to install now is the TBS TS recorder. So this application uses the satellite card on the computer, whether it's a USB or internal PCI, and actually grabs data from the satellite in its most simple way of putting it. So we're just going to install TBS TS recorder now. So just go next, install, and then finish. And I believe that's all we need to do for now. So now what we need to do is we need to install the star of the show, and that is GSE extract. So this is a bit of a, this is going to take a little bit of time. This is not a quick tutorial, guys, okay? I know a lot of you guys don't like these long form videos, but hey, if you want to be a super cool hacker, this stuff takes time. So what we're going to do now is I'm going to open up a PowerShell window as administrator. We need to run a couple of commands here. So the first command we're going to be running is pip install GSE extract. Pip is a Python package manager, and we can install Python applications using pip in the command line. So I'm going to hit enter on that command. And we can see it's downloading and installing GSE extract for us. So there seems to be a problem with GSE extract when you just download it directly on Windows. So it's actually missing a dependency. So we're going to install that dependency, and we are going to type pip install setup tools, one word, and hit enter on that. Okay, that's all good. All right, now what we have to do is we have to edit one of the GSE extract program files. So there's some kind of error that prevents, so it just makes GSE extract stop decoding for some reason. I've narrowed it down to 6 lines in the code, which is causing the error. So we need to actually comment out those lines. So I'm going to put this path in the description. We need to browse to that path there. So I always name my virtual machines or anything that's not my main computer just as username, as the user account. But you'll probably have to edit that to reflect your own Windows account. So mine's username, yours could be Bill or Tom or Matt, I don't know. I'm going to hit enter on that. And we need to edit this file here called gse_parser.py. So I'm going to right click on it. I'm going to edit with idle. Edit with idle. Idle is like the Python like text editor, I guess. We're going to go to options, show line numbers, and we're going to scroll down to line, I think it's 167, starting here, right here. And what we're going to do is we're going to add a hash symbol to each line, like so. So we need to do this from all the lines from 167 down to 172. And then once you've done that, we go to File, we go to Save, and then we can close our Python text editor. And yeah, that's all we need to do for now. With that, I can close this file browser window now, and then hopefully, if we simply run the command GSE extract and hit enter, we can see it's working just fine. We've got an error here, but that's only because I haven't sent it any arguments yet. We'll send it arguments very shortly. So now this is the fun stuff part. This is the fun part, guys. So now what we're going to do is we're going to actually capture some data from the satellite. So that's really fun. I'm not going to tell you guys which satellite I'm doing it on. because I don't want you to copy this video, reenact this video and be naughty. So I'm going to go run as administrator on the TBS-TS recorder. If you don't run it as administrator, it just won't launch. It needs admin permissions to launch this program. So this window here will list all the DVB-S2 devices that are currently connected to your computer. I only have one on this virtual machine. So I'm going to double click that or highlight it and click OK. And you'll be greeted with this window here. So this is the TBS recorder application. So I'm not going to go too much into hardware, but I've got a universal LMB on board, okay? So universal LMB is the thing that attaches to the satellite dish that receives the signal. The signals bounce off the dish and get absorbed into the detector in the LMB. So I'm using a universal LMB, which is the stock standard settings of TBS recorder. So I'm not going to touch my LMB settings. So the frequency I'm going to be targeting on this particular satellite is on a frequency of 12, 7, 717, oh, hang on, numlock's not on, 12717 megahertz. So that's 12.717 gigahertz. The symbol rate is going to be 9,563. The polarity is horizontal, and then the output stream will change to GS, and then we hit lock transponder. Not every transponder is different, right? You won't be able to target your satellite in North America or Europe and then just enter those settings. It won't work like that. This transponder is very specific to this satellite, and it doesn't exist anywhere else, okay? So you have to do your own hunting, feed hunting, I guess you could say, and find your own generic stream encapsulated IP traffic transponder to decode. You won't be able to emulate this, okay? So we've got a successful lock on that signal, which is indicated right here. The next tab we're going to go to is capture control. And then this is where we're going to save the file to. So I'm just going to save it to the desktop to keep it nice and simple. And then I'm just going to call it dump.ts. Hit enter. Let's just capture 50 megabytes. It'll probably take a while to get 50 megabytes. I'll just try and get 20 to keep the tutorial nice and short, but the minimum we can write is 50, so I'll just write that. And then we'll just hit start record. And yeah, very quickly we can see the data is being captured and written to this file on the desktop here called dump.ts. So that's really cool. Oh yeah, so I don't think it's going to take too long to get about 10 or 20 megabytes, so that's pretty cool. So what I'm going to do is I need to CD to my desktop. Sometimes GSE extract, I'm not sure. I was practicing recording this video today, and for some reason it wanted to always run as administrator, but sometimes it doesn't run as administrator. I don't know. So this is an admin terminal, and I'm just going to CD to my desktop. And then, like Linux, I can just write ls, and it shows me that my dump.ts file is located right here. So we'll just get about maybe 10 megabytes just to keep it. This video is getting pretty long now. We're at 20 minutes already. So yeah, we'll just get 10 megabytes. All right, that should be close enough to 10 megabytes, I reckon. So I'll just hit cancel record. And yeah, essentially we've got a transport stream file here. So this, hopefully, has internet traffic encoded into it. And now this is the fun part. We can actually utilize GSE extract to extract that IP traffic and put it into a .pcat file, which then we can open with Wireshark, which is really cool. So I'm going to type the command GSE extract. I'm going to put the name of the file that we just captured. I'm going to put a space and then write dump.pcap. And then we're going to hit enter on that. And then we have it. That's saying corrupted data, but that's just the penalty we're paying for using a 5927. The TBS 5927 can't handle baseband frames natively. So I guess it's kind of like just brute forcing and guessing. Whereas like the other cards such as TBS 6903, TBS 6908, the internal PCIe cards, they actually have native handling of baseband frames. Not really sure how it works, but I've read something online that they take the baseband frames and then encode it into a transport stream, and that's the file that you're getting dumped to your computer. But this still, using the 5927 works anyway, even though it's not the best way to do things. So yeah, after a short amount of time, we now have a 12 megabyte PCAP file on the desktop here, which is really cool. So I'm just going to double click that. And then Wireshark will open. And then we can start analyzing some of the traffic here to see what we've got. So I'm just going to open that up. We don't need this part here. We don't really need that there. I'll just put that there. So yeah, so here we have it. This is IP traffic, which is not meant for our eyes. Displayed for us right on the screen here. So yeah, just at first glance, we've got some, what kind of traffic do we have here? Lots of TCP packets. We've got nothing really terribly interesting at the moment, but yeah, let's just see what we've got here. So, I don't know. What about emails, guys? Everyone loves a good email. Let's put in POP. Okay, there's no POP email traffic. That's all right. What about SIP? So SIP is like a voice over IP. So yeah, we've got lots of SIP packets there. This is like SIP. They're not like voice packets. These are just like control packets, I guess. Link control packets and so forth. What about HTTP traffic? Yeah, so we've got a bunch of unencrypted HTTP traffic there. What about DNS traffic? So we could see like the DNS requests made over this. So we've got a list of like you know, DNS requests from that. What about SMB? So SMB is like file, like sharing traffic, you know, like you know, when you share a folder in Windows or whatever, the data's transmitted over SMB. What else have we got? Let's try one last thing. What about LDAP? I mean, we've got like LDAP traffic there. So LDAP is like our Windows Active Directory, I'm led to believe. So yeah, that's really how you do that. I'm probably going to end this video and make it like a part 1. And then in part 2, I guess we'll configure Linux and do it a better way. With this way, you sort of capture the data first and then you decode it later. If you use Linux, so you use the Windows application to record the transport stream file, and then you can use Linux to decode it live, and you can see the traffic coming in live. So that's what we'll do in part 2. But yeah, that'll end it for part 1 anyway, guys. I hope you enjoyed that. Thanks very much for watching. Bye.